that first to explore this. This is the command you have to go through. Docker compose of -d. So this will bring up all of your application up and running. Docker PS. So this is front end, this is back end, this is MongoDB. You can go from here, localhost. This is JPMC Bank. Uh, that's how you can log in, sign up. Let's say Deepak. Then mobile number. Account opening, let's say gender, branch, password. And this one, so if you go here, sign up. Okay, you successfully registered. You save, login. I was putting wrong password. So here, this is how you will see. This is how application is working. I haven't explored it much, but this is how you will get to know, or you will see everything. So this is the first step, how you will be getting like exploring all of those things. So there is also, you can connect this through your Mongo. This is what Mongo Compass you can download from like their official page. And according to your operating system, you can just go and explore. There is a issue with this application. You need to explicitly upload this branch, else you will not be getting, you will not be seeing this branch while signing up. You will not be seeing this branch. So you need to explicitly upload this thing. You can just go here, JPMC Bank, connect to the database, and then you can select a branch and let's say you can delete this or add dataset. You can just add the dataset through JSON document. And this JPMC data, I have basically put this JPMC branch in here in the dataset. So everything is like available. You just need to put this one because currently the application is not written in a way you will get like this branch will get populated automatically. So this is what the application you will be seeing now. So is this thing clear, like till here, how to bring the application up using Docker Compose? Yes, no. Any question?
No,
Hello.
Deepak.
Okay. Rest.
Yeah, nothing from my side.
Okay. Yeah, that's good. So the next thing is that yesterday I have discussed this thing, like all the deployment file is here. So let's go through one by one. So like in Kubernetes, that thing I have covered, like how to bring up EKS cluster on your local. Let me go through and explain you. So we have bring up our local EKS cluster. If you see here, this, let's go to here, EKS can come here, and the documentation we have shared, using that document only, I have brought this cluster up with two compute node or worker node. This is one. So everything is well documented. You just need to go use EKSCTL command to bring this stack up using the documentation which I have provided. The documentation is here. I can share this thing again. Yeah, this one, and create a quick cluster. I think I don't have permission to share from here, but we have shared this thing. The same thing you need to follow one as it is. So when you do this, your cluster will be up. The next thing is that uh, you deploy application. How you deploy application? So in Kubernetes, when you deploy, so currently if you uh, when you bring cluster up, so kubeconfig you will be getting, and it will be set, like it will got set up into your system by default. kubectl get no. So this is the same worker node which got provisioned, which I recently show you guys, like this one. This is the two same worker node which I got in the terminal section. Here if you can check 109.97, 172, 228. This is the same IPs and same identifier of the compute node. So now the next thing is just to deploy the application, this front end, back end, and the database. So how you deploy? You deploy using this services like this deployment file. So you can see front end deployment, back end deployment. So how you deploy? This is the image you need to put, and this is the deployment object you have to use. You don't need to basically by heart everything. Uh, so you can go here in the Kubernetes deployment to check how deployment manifest got written. This is the sample one. This is the same thing I have picked up and I have put at this thing here. But the one thing I have changed is that this is the image, because while running the CI/CD, I got this image from my ECR. The ECR, where is your ECR? ECR, I have shown you this thing yesterday. This is AWS managed Docker Hub, you can say. So this is the same URL I have put. I have just copied it from here and I have put this thing here. So when I apply this thing, my Docker container or application will get deployed as a container in my Kubernetes cluster. So this is the similar step I have done with the front end too. So this is the only image I have put, and the container port, because the front end is running on 80 port through Nginx and the backend is running on 3000 port. If you look carefully, this is the same port mapping I have given in the Docker Compose file. This 3000 port mapping and this 80 port. So this is where your application will be listening. So this is deployment is nothing but the Kubernetes object, which will help you to scale out up to manage like how many instances of your application will be running. Like here I have put replica ones, means when I deploy this application in my Kubernetes cluster. So let's say, let me delete this. So let's say this is my Kubernetes cluster where my multiple worker nodes are running. Currently, there is only two worker node. Let's say this is worker node 1 and this is worker node 2. When I deploy any application of name backend, backend. So with Replica 2 means the two instances of this application will be running in my Kubernetes cluster. So, but currently, if you see here, Replica means one means there is only one instances of my application will be running in my Kubernetes cluster, either in this node or either in this node. So this is the meaning of this. So all of these things are by default setting. This is nothing but the request limit which I have put. So I am explicitly telling this Kubernetes cluster that I want to run this application container with one instance, but provide CPU and memory of this much configuration. So this is what I am telling. So similarly goes to front end. Front end deployment. This is the same spec, just change the container port and this image you need to change, and memory or request limit you need to tune according to your requirement, how much memory on CPU you want to put. So this is what we have done so far. So let's say your application is deployed here and with the front end and the back end, let's say this back end, like they can be deployed in anywhere in any of the nodes. Uh, Front end. Okay, this is the container which will be running in your like worker nodes, either in front end or back end. This can be running here, either here or either here. This can be controlled like where you want to run these instances. This is a much more advanced concept, but ideally this is what we have set up so far. Then again, the next thing is that this service. So, so when you create any container, this container basically comes and goes. These are like ephemeral in nature. They can, and their IPs got changed. So what Kubernetes suggests, if you want to expose this application, uh, so there are services, different services are there. So one of the services is that ClusterIP. Sorry. Cluster IP. So this is nothing but a static object whose IPs will not be getting changed. So this you deploy here. Why? Because you want to expose this application publicly, but you need a static object because these containers are ephemeral in nature and their IPs got changed. But this static object, the cluster IP will not be getting changed. If you bring this application with an instance of two, behind the scene, this cluster IP routes the traffic internally to them in a round robin fashion. So that's why we are using cluster IP. There are another more services are there, but in our scenario, we are using this thing, and another services have a very different use cases. You can expose this application and map it to your node port explicitly, but there you are directly exposing your pod or the smaller containers directly through your node port. There you will not be getting the feasibility of this multiple instances running behind a single, like it's like a mini simple small load balancer behind the scene these backends are running. So it's a simple concept, and this is the same thing we have done here, cluster IP, and then the target port and port. These are basically where your traffic will got like the traffic will land in the services of name this, which port this service will be listening, and this is nothing but the target port. If you see here explicitly, selector app means backend, and if you go here, this is match label app backend means this is how you stick your cluster IP with your backend is nothing but this labels, selectors and match labels will help you to stick any of the deployment with the services. So if you carefully see here, selector, app, key, and value backend. And if you carefully see here, selector match, key, app, and backend. So uh, this is the selector, and this is the label, like the selector. This attribute and this attribute should get matched to basically map this service with the deployment object or the container to route your traffic to. So this is how you map your application through label selectors. So is this thing clear? Similarly, if you see here in the front-end services, app, front-end, selector which I have given. And similarly, if you come here, here you can see match label app front-end. This means your traffic will first land to this front-end service, then it will route your traffic to your deployment front-end, which is getting matched. So this is how you provision or you deploy your services. So fundamentally, this thing is what is happening. So is this thing clear, or you guys want any confusion are there? Yes, no.
Yes, clear.
So this is the mapping you can see here. Pictorially, this is what happening. There are much more component, but to make it very simple, like this is what happening behind the scene. Now, if this thing is clear, let's go to another one. This is same thing happening with the this one, MongoDB. Ideally, this is not the good way to do in production. I will explain why I have used this thing. This is just for learning purpose, but in production, like how you do. Currently, the scenario is that to deploy a document like MongoDB in AWS, you need to have a subscription. That's a chargeable one because that's why I have not purchased it. But for learning purpose, we can use this thing. But ideally, how you do, you basically use that uh, manage services and then use a service name. The service name here, which we are using here, is that cluster IP. But at that point of time, when you will be having database managed database service or your own managed database service, you will use external service of name external DNS. So through which you can provide like which how your traffic, how your backend will get connect to your database. This is how you do. But let's first complete this thing, then we can go to that discussion. So here you can see this is nothing but the cluster IP, but the here you are not exposing your application. These are currently running in a very isolated way. So we have covered basics. I have told you like there are service of type load balancer. So there are a lot of services. Those service of type load balancer if you use. So to expose, you can basically put your service of type load balancer here. But ideally, what will happen is that when you put load balancer, so your uh, there is a load balancer which got created in your AWS account, but let's say this is single microservice. If you have a tens of microservice and you are using services of type load balancer, so you have 10 or 20 load balancer which is getting provision for each microservice or for but this is like very much costly solution. So how this like community came up with, there is an object called Ingress. So what you do, you provision only one single load balancer. This is the single load balancer. and you expose all of your microservices through this. So that's how. So when it comes to this load balancer level in AWS, it provide a lot of mappings, DNS-based, host-based routing, path-based routing, header-based routing. So all of those rules you can use to do. Uh, this Ingress support two type of routing, path-based and host-based routing. You can like explore this thing. So what it does, if you carefully see here, this is nothing but Ingress object I have written, and I have written a rule like whenever like create a load balancer of name this banking application Ingress, like if there is Ingress object which will got created using this of name this application bank application Ingress, and what will be the class? It will be a load balancer of class ELB. Internet facing means public load balancer, then target type of IPs. Then it forwarded to port 80. If you carefully see here, I will show you a load balancer which got created. And okay, this got removed because I have deleted the ingress object. If you see here, kubectl get all -n banking application. Currently, there is nothing. Let's go and deploy one by one. Deployment. First, let's deploy this database. kubectl apply. This, you do this. So how you do this, you do kubectl get for -n. If you see here, this is running. Okay. Now let's bring up our backend. kubectl apply -f. Let's deploy this first deployment. First deployment goes, then services goes. kubectl apply -f kubectl for -n. Here you can see your backend is up. So for each and everything I have written, like there is deployment file and there is a service file. So what is the precedence you follow? You basically deploy first, like deployment file, or basically you can write everything in one single file, but for bifurcation, I have written this thing in a different file. You can basically write this thing, each and everything in one file, like all of the configuration in one file. But to bring more file bifurcation, and it will make you like more comfortable to like connect everything, like what all things are going on. It's step by step. That's why I have splitted everything. So now let's go to deployment of kubectl apply -f. This front end, then front end. So currently what I did is that I have deployed this front end deployment. Now I am deploying this service. kubectl apply -f service. So if you do here, okay, now your this whole stack is running. kubectl get svc means service. It's a short form of service. Then namespace I am basically providing bank namespace. So this is nothing but the cluster IP service which got created. So is this thing clear? We have basically bought this thing up, this whole stack, and there is a database running. It should be running either here in or here. Let's say MongoDB, and there is a cluster IP running above this. Mongo service, let's say. Okay, so this is what we have done so far. Now let's go to this load balancer part. So till here, like everything is clear. Everyone, each one of you got the understanding.
Deepak, can you repeat the last bit once?
Which one? Which one?
Yeah, the last one. I actually lost network in last 15 seconds.
Okay, so basically what we have done here is that we have deployed backend deployment, front-end deployment, and expose those through services. I haven't done anything explicitly, but what I have done basically kubectl apply -f, and I have applied this, and this file, and also this file. So far we have covered this file except this one. We have deployed anything. You can deploy, like you can provide multiple manifest file at a once, or but we have deployed it each and like each individually. Like this is what we have done so far, the deployment of this thing. Now the next thing is to deploy, like create an Ingress object. There will be an Ingress object which got created in the cluster, which we have written here. And there is a mapping we have done. Like if I hit this, where my application will request will go. If I hit this, where my application request will go. So like those kind of things. Let's provision this thing, kubectl apply -f ingress. If you see here, kubectl get ingress -f. There is ELB, which is getting provision. Let's see here. This is running in Mumbai region. So here you can see your ELB is getting provision. There is a rule which got created, banking application.example.com API this.com API.banking application example.com. This is the same one I have put here. So what I am telling is that when I hit banking, like banking application.example.com, so what will be happening is that behind the scene, if I hit somewhere, like I am sitting here somewhere in the globe, and what I am sending banking application.com, so there is a much more complex thing happening, but let's say I am doing from my home. So the request will go to here, this load balancer. And this load balancer will judge, let's say this is then where I have to send. So what I am doing, if you get this, forward it to your front end service. Means if you get this, there is a decision going on, forward it to your front end service. So this is what happening at the load balancer level. If you get this, then forward it to your backend services. Okay, I have put this thing very wrong. So this is what happening here. If you get this, forward it to your backend. If you get this, forward it to your front end backend service. So how you identify that I am saying the right thing is that here you can see there is banking application.example.com, and here you can see carefully KTS front end. So your traffic is going to front end, and here you can see this is the IP of your frontend pod, the container which is running. This is the IP of this. I believe you can see the IP kubectl get o-o wide -n bank kubectl get o-n bank -o. There is a wide command, is there? Oh, there is a wide command. -o wide. Okay, this I have to put. You can read it in the documentation. I'm just in hurry, that's why I haven't gone to the documentation. Here you can see you also got a lot of information from here. This is the IP of your front end 192.168.164.6. If you come here, this is the same IP. So is this thing clear, like how you map this thing with your Ingress object? This is the whole configuration. You need to go it in a very iterative way, like how this thing is happening. But you need to read about this Ingress object. Ingress. AWS, sorry, Ingress K Kubernetes. So nothing I have like memorized. This is what reference I have picked up, and concepts I have basically concept I know. So that's how you do service mapping and ingress name, then the path-based routing. So this is what I have done. Basically, I want to do host-based routing, and if I got this, I need to forward it to my front-end service. If I got this, I want to forward this to my backend service. Let's go and see this thing. Docker. I want to show one more thing to you. So this thing is building again. Localhost 3000 if I do. This request is coming from your like backend, this Docker PS, this backend, which is running currently in my local container, like through Docker Compose. So let's see this. So there is a test thing I have written here. You can check how you test, like your request is going here. So I'm not sure like how much of you are aware of this. You can do basically host-based routing through curl. There is a utility curl. You can use this to send the request. Let's grab this. How you test this? Let's get the ALB DNS first in the environment variable. Okay, I have put this thing in the environment variable. You can pick this up. You can basically, you don't need to memorize it. Basically, I'm getting everything from here. Kubectl, I'm setting environment variable like my load balancer environment variable. You can just go and hit this. So this is nothing but the load balancer which is getting provisioned, and you can see from here. It's the same Elastic load balancer, load balancer DNS. here you can see this is the load balancer DNS create as bank application, then the whole new record. This is the same thing. So basically I am picking this thing from Kubernetes. This is the same thing. You can search from here. So what I am doing is that I have set this thing in my environment variable. Why? Because I want to send a request to that load balancer. If I send this, then what I will be getting? Let's try with a backend first. You will get a fair idea. Like you will be getting HTML of which will be written. What you will get this in the response express. This is your browser. You cannot send explicit host-based API call through this. That's why I'm using this curl API, curl utility. Now this is dynamic because I have populated set the environment variable, and basically I'm telling this utility send a host-based routing, and this path, this host basically you need to send. If I say this is Express, welcome to the Express. If you see here, this is the same response. This is currently the local container, but this response, this whole response I am getting from where Kubernetes backend, the backend which we have deployed in the container from here. So the API call is going, and there is a, let's go to here, Elastic Load Balancer. So once the, oh, where is the, okay, so the API call lands here through this DNS, and it comes here, and there is a rule you have written. So let's say if you are hitting api.bankingapplicationexample.com, since I have sent this thing, so now it will go inside this rule too, and here it will forward it to target group. If you go inside here, there is a backend which got deployed. The backend container is running. So the response we are getting from here. I think we can also check kubectl logs. kubectl get po-n. Then what? Banking application. You can check kubectl logs -f. This one. So there's the 200 response it is giving. I think I can hit it again. So there's a health check going on. Basically, load balancer is checking if this is running or not. So this is what's going on. So similarly, you can test your front end through this, I believe. Yeah, you can send this curl. Currently, you will see this whole gigantic HTML, CSS, but this is the same thing. This is the same HTML content you are getting from here. For what you are getting localhost. This is the same HTML content currently we are seeing here because there is, I don't have any that DNS currently to show you all the mapping that all how this routing going on. So ultimately what will be happening, I will try to get, there is a domain to show like how the flow is going on. So whenever you hit bankingapplication.com, or let's say xyz.com, if we have xyz.com, so what we will be doing on, we will be creating a Route 53 entry. So, and this load balancer DNS, we will register in load balancer, like in Route 53. What is Route 53? You can just come here, and it's a service provided by AWS. So we can create a hosted zone here, and we can map, like let's say I have xyz.com or bankingapplication.com. We can map it through here. Domain registry create. I think we need to purchase it. But I will show you, like I'll try to show you this flow. Currently, I don't have domain. That's why I'm showing this thing from here, the terminal. the request is going like this way only. If I get this thing tomorrow, like I will try to figure out like how I can show this thing. But at a high level, like you guys got the understanding like how the request is going on from load balancer, then decision making going on, then target group, then splitting it to services, then it is landing from services to the container. This is what happening behind the scene. So far, like, is this clear or you guys have any doubt?
Yes, Deepak.
Rest?
Yes, it's clear.
Okay, great. So one more thing I haven't explained you because that will make you much more overwhelming. But we'll cover this thing tomorrow because Ingress is quite complicated stuff to explain. But I want to suggest you like, please go through this. We will cover this thing tomorrow because I have shown you a very much top level overview, like what all things going on, but there is a much more deeper thing like going on inside this. So when we gone through the Kubernetes architecture, there is a component called cloud controller. So when I created this Ingress, did you guys notice like this load balancer getting provision automatically when I was showing this thing to you? It was in provisioning state. Currently it's in active state, but when I was showing this was in provisioning state. So what is happening behind the scene is that there are certain cloud level configuration we have to do to make like to make Kubernetes to make this Kubernetes allow to provision any resources in my AWS infrastructure. So there is a full-blown uh, thing going on. So you can read the documentation from here. Uh, just go through this because I covered this thing in this like in this session. It will be much more overwhelming for all of you. So just go through this, like what is AWS control, a load balancer controller, how you provision this. Like just go through this. If you are not understanding, that's completely fine. We'll cover this thing, but just go through this documentation, like how this thing is happening behind the scene. But the summary of the session is that I believe you guys got the understanding how to deploy it locally and how to map services deployment, and then the load balance and ingress rule, all of those things. This understanding, at least you guys have got.
Yes.
Okay. If you guys can cover, like, if there is no doubt, we can wrap it up today's session.
Yeah.
Okay. Thanks. Thanks,
Thank you.
everyone.